They're asking you a question, first off. They have the exact same letters to represent these lines, but the questions are actually representing two different lines. So, if you notice, this one doesn't have any arrows at the end, okay? So what that means is essentially it stops. They choose not to draw little circles, but usually in elementary school you draw little circles because this represents line segment, okay? So this is a line segment. Now in your other one, there you go. Imagine that's one line, okay? We have arrows on the end, which means that's a line, okay? So in words, there's not a big difference. Essentially, one's a line segment. But in terms of what they do, a line segment has ending points, okay? So that's why they don't have arrows at the end. So what they're saying is at some point this will end. So it has a definitive distance. So there is a distance I can measure to it. I'm not sure how long it is because they haven't given it to me. With a line, this is infinite. It goes on forever and ever and ever. So it never stops. So anytime you have line written with two arrows at the end, that means it's a line forever. So there's actually really no measurable distance. If your teacher ever asked you the distance, because you guys have done distance formula, have you ever seen infinity as a sign?
Yeah.
Yeah, it's like a sideways 8. That would be the distance to this line. Okay, it just goes on forever. While this one would have a specific number depending on what the points are. Does that make sense?
Yeah.
Okay, so it's just a difference between symbols right there. Okay, question number 2. They asked us to find the distance between point 8, 6, is it?
Yeah.
Okay, so we look on our graph, x is 8, y 6. So here's our point, 8, 6. They want the distance of that to the origin. Well, the shortest distance will always be a line, okay?
Yeah.
So they want the distance of that line, okay? Do you know your distance formula off the top of your head?
Is it x?
Usually they set it up as d is equal to, okay? And then it's a big square root.
Oh yeah.
You ever seen that?
Is it x2 minus x1?
Yeah.
And y2.
Well,
Oh, 8
no. Do you use different letters? I don't. Usually x2 minus x1 squared.
Oh yeah, squared.
And then plus y2 minus y1. Does this make sense?
Mm-hmm.
Okay. So here's what's important. Because we have an x2 and a y2, sorry, x1 and a x2, in other words, we have x1, y1, so we have one coordinate, and because there's an x2 and a y2, this is our second coordinate, we need two coordinates on this line. Let's get to. We know we have 1, 8, and 6. What would another coordinate be? Or in other words, where does this line end?
At the 0.
At the 0. Do you know what that coordinate is exactly?
Is it 0, 0?
0, 0. Okay. So there's our other one. So we're going to call this coordinate 1 and this coordinate 2. Okay. So we go to write them down. Coordinate 1 was 0 and 0. So that was my x1 and y1. It's always good to write on top because with a lot of the formulas in this chapter, it can get really confusing which number goes where. Okay. And our second coordinate was 8 and 6. So that's going to be our x2 and y2. Does that make sense why I call that x2 and y2? The x always goes first and the y is second. Okay. So we have our second coordinate. So now all your steps are, I'll rewrite it again down here, is you need to plug those coordinates. I should do distance formula with this so it looks like a straight line. That's a little better. Into this formula. x2 minus x1 squared plus y2 minus y1 squared. You want to give that a try?
Yeah.
Try that out. Okay, so you plugged it all in, you're right, you figured out it was 10. Okay? I'll show you a trick with the distance formula. I'm going to create something here with a dotted lines. Okay? Down here and across here. What have I just created? What shape?
Triangle.
Triangle, right? Yeah. And what part of the triangle is this considered, this long part here?
Yeah.
It's called the hypotenuse. Do you remember any formulas to find the hypotenuse of a right angle triangle? Do you ever remember hearing of one?
Oh yeah. A squared.
Yeah. Pythagorean's theorem, right? So you get c squared is equal to a squared plus b squared, right?
Well, I could have just done that. No.
You can create triangles to solve these. Is the exact same thing, right? Because if we count down, the distance of this is 1, 2, 3, 4, 5, 6. So I'll write that out here in green. You know the height of that is, or A or B, 6. Remember, it doesn't matter which is A or B. And from here to here, we know it's going to be 8. I can count across 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's 8, and we're looking for the hypotenuse, right? We just created a triangle around it, so that'll be our C. I'll show you how similar this is to it. Okay, so what ends up happening is, if I were to bring this square to the other side, I would get C is equal to the square root of, same idea as this one here, a squared plus b squared. The only difference is, instead of putting in coordinates, I just went and counted on the graph, right? Now, we might not always graph it, so this formula, your distance formula, may be best. But if you have a graph, you can always turn it into Pythagorean. So let's say this was side A, we'll call it, and this was our B, okay? So A was 6 squared, B was 8 squared, equal to the square root of, just keep it there, just so it looks similar, okay? 6 squared is 36, 64. Is this looking very familiar to what you just did?
Yeah.
Square root of 100. 10. All right. Ever get stuck with the distance formula, or you want to check it? Just make a right angle triangle and do that Pythagorean theorem. Okay. Does that make sense?
Yeah.
So this is question what? 4?
Yeah.
4. Okay. So you look at it. It's more important you look at it. Question number 4. All right. We're doing circles now. Okay. So these are graphing circles. Equation of a circle is x squared plus y squared is equal to r squared. Okay. R stands for the radius. Is ringing a bell now? Radius. Okay. All of our circles in this equation's form, the center of them is at the origin. Okay. No matter what the circle is, the center is at the origin. So I'm just going to make sense of this here for a second. Wasn't perfect. That's roughly what we're doing. Okay, so the equation of this circle, essentially the only thing I need to find is the radius. Okay, so if I look at this circle, I know the center is right here. How could I find the radius of the circle? Do you know?
Find the square root.
That would be the square root of kind of what an r is. The radius of a circle is just from the center to the outside.
Yeah.
Every one of these lines I'm drawing is technically the exact same length. They're all the radius, okay? And if you look, I can literally count to figure out what the radius is here. If I count up 1, 2, 3, 4, 5, the radius of the circle I just drew is 5. So when I go to write the formula, x squared plus y squared, what was our radius we just said?
5.
Yeah, 3, 4, 5. So our radius was 5. So instead of r, I put 5 squared. And I just have to equate 5 squared. So x squared plus y squared is what? What is 5 squared?
25.
25. So that's the equation of that circle right there. Okay. Now the first question actually asks you, graph the following circles and state the xy intercept. So I use the exact first equation they did. We have x squared plus y squared equals 25. Okay. To find the radius, if they given it at us, you're right, we would square root that number, and we would have found that it's 5. Now, what are the xy intercepts? How many of them are there with this circle?
2 of each.
Yeah, that's right, 2 of each. So we have a y and an x. Okay. Here's our first xy intercept. What is that at?
It's 5.
Yeah. 5 and what's the other coordinate? X is 5, y is
5.
not quite. If we're on the x-axis, this is a point.
0.
0, yeah. What about this one here?
0 and 5.
Hey, there we go. Now you're getting it. What about here?
Near 5 and 0.
Yep. And finally, I know that one's a little off. It's
0.
supposed to hit 5.
0 and negative
0 and negative 5. So those are all the xy coordinates. These are your y's. Okay. I should have done them Those are our y-intercepts, and these are our x-intercepts. Okay. Do you notice anything about them? The radius of this circle was what? What was the radius of this circle?
25? No, sorry, 5.
Yeah, just 5. Radius was 5. If you look at these, all of our x and y intercepts relate to the number 5. Okay? And it's always going to be like that. Okay? So I want you to try one of those questions. So, they're giving you 2 tough questions. We'll just quickly review so that you know. First one was, let's say, 6. They gave us a radius, and we'll do a different radius. We'll say it was 6 and a third, maybe. So it's even harder, okay? 6 and a third. Well, we know we need to get x squared plus y squared equals r squared. Our radius is 6 and a third. So I'm going to change it to an improper fraction. So 6 times 3, you need to do that, plus 1. That gives us 18 plus 1, 19 over 3. Okay? So I know this is 19 over 3. And if I divide that on a calculator, I'm going to find out what the decimal is. Okay? 19 divide 3, you're going to get a long number. Yeah, 6.3 forever. Okay? So we're just going to round it. We'll just say it's 6.34. Is that good? Round the 2 decimal places. So now, this is our radius. In other words, that's what r is equal to. So I get x squared plus y squared is equal to 6.34 squared. So I'm going to square that number on my calculator. For me, I just got to hit that. 40.1 forever. So we'll round that again. So we get x squared plus y squared equals 40.11. That's it. Okay? Does that one make sense?
Yeah. Are you supposed to only do one decimal number?
Maybe your teacher only wants 1. If she only wants you to round it to one place, then that would round to 1, and this one would just round to 3 kind of thing. Okay? Either way is fine. 7, they give you another one. X squared plus y squared equals r squared. But they told us the radius, let's say we'll give you a different one, is the root of 8. Okay? That's a hard number. I can't find the root of 8 in my head. I'm not quite sure what it is. But luckily, when I plug it in for the radius, right? So I replace r with it, root 8. And then I still have to put to the power of 2. This sign here, a square root and the power of 2, they cancel each other out. So this is really easy to find the equation of a circle. X squared plus y squared is equal to what?
6 squared? No, sorry, 6.
We're not using the number 6.
8.
Just 8. Yeah. Does that make sense? Does that make sense? Okay, number 9 says the diameter of the circle is 100. So origin's at 0, 0, which in order for us to make these equations of a circle, x squared plus y squared equals r squared, it has to be the origin or the center of the circle has to be there. Okay? They've told us the diameter is 100. Do you know how to find radius from diameter?
Times that 2.
It's the other way around.
Divide by 2.
Divide by 2. Yeah, diameter is twice as long as the radius. So the radius of this circle would be 100 divided by 2, which is what?
50.
50. So I plug that in for r. What am I going to get? X squared plus y squared is equal to
50.
Yeah. Square. And then when I do that,
5,000.
no, we'll get
Yeah.
2,000.
2,500.
Yeah, that's right. 2,500. And there's the equation of that circle. Make sense?
Yeah.
Okay. Okay, so here's the equation of a circle again. Okay. This time, though, this circle, this circle here, where would the center be? Center of this circle. Is this where they use h and k? Yeah, this is where they use h and k, right? So their equation is x minus h. Is that what she probably uses?
Yep.
Squared plus y minus k squared equals r squared. Okay.
What would you use?
We don't go into depth into moving circles, but you can use these variables. Okay, so h and k. What's important here is h deals with movements along the x-axis, so horizontally. Okay, horizontally. So that's moving left and right. K deals with movements up and down on the circle, the y-axis or vertically. Does this make sense? So according to our other question above, our h is what number?
4.
Yeah.
Is it negative or 4?
Let's think of it as 4 right now. Okay, positive 4. And your k is
And k is
-2.
negative 2.
Okay, I didn't know. When we go to find the actual center of this circle, we always use what in comparison to these numbers? If this is positive 4, what's our h actually represent?
Oh, negative.
Yeah, so the center's at -4. That's our x value, and positive 2. That's our y value. And what would the radius of this circle be?
100. No, sorry, 10.
10, that's right. We always got to find the square root of it. So our radius is 10 in that circle. Does this make sense?
Yep.
Okay. So we have a circle here, and they've given us a line that represents a diameter. What that means is diameter goes through the middle of a circle. Okay? So that's goes right through the middle of the circle, and it would be the longest distance of a circle. Okay? The diameter, or sorry, the center of the circle is going to fall where in the diameter? Do you know?
In
In
the middle.
the middle, yeah. It's going to fall right at the midpoint. Okay? So the midpoint of a diameter is the center. Okay? So if the midpoint of the diameter is the center, we go over to our other question. We have a diameter here of a circle. Right? We need to find the center of the circle. What formula would I use?
The one at h.
That will give us the equation of a circle, but we'll still need the center. We still don't know what the center of this circle is, right? This is all they've given us so far. The diameter, this is at 3 and 12. What part of the diameter is the center of the circle? Where on the diameter? Would it be here? Will this be the center of the circle?
No,
Down here?
in the middle.
In the middle. What formula am I going to have to use to figure out the middle? Because I don't know what it is. By looking at this, it could be anywhere in there, right? So what formula am I going to be using?
C equals.
Remember that one we just did? Do you remember this formula?
Oh, yeah, x.
Yeah. We're going to need to use our midpoint formula, right? So we need to find the midpoint
Oh, okay.
of this circle, right? So let's try plugging those in. Okay, so let's say you plugged all those numbers into the midpoint formula, okay? So we plug these in, and we discover the midpoint was at -3 and 3. So that means the midpoint of the diameter, or the center of the circle, is at -3 and 3, which is great. That looks like it would be the exact center of a circle. So when I go to actually draw this, because I actually have to use the center, that's about right. Okay, so there's our circle, right? Our center is at 3 and 3. This thing goes slow sometimes. Okay, so it shrunk a little, but that's still fine. Our center of our circle is at -3 and 3. So here's the important part now. We have the midpoint, okay? We need to find the equation of this circle. We knew the equation of the circle goes x minus h squared plus y minus k squared equals r squared, right? Do we have our h and our k?
Yeah.
Yeah, we know here's -3 and 3, right? So I'm actually going to plug those in. We knew that h is -3 and k is 3. I'm going to plug those in for h and k specifically. So I get x minus, what's h?
H is negative 3.
-3 squared plus 3 plus 3. So positive 3 r squared. So this part of it, let's equate it. What is x minus -3?
It wouldn't be x plus 3.
Yeah, right? Which is the opposite sign, like we said before, right? And we're just going to get y minus 3, right? Well, there's one piece of the circle we're missing. What haven't we found?
The radius.
Radius. How am I going to find the radius of this? I know that it's got to go from the center of the circle to what?
It didn't need two.
It's just got to go to one of the outside points, right?
Yeah.
So what am I going to have to find? If this is the radius, what formula do I have to use? Because I got to find how far this is.
A distance from it.
Yeah, distance formula. So I'm going to need to find the distance between the middle of this circle and one of these points. So let's use that distance formula. Do you remember it? We'll go down. Go next page. Distance equals the square root x squared, x2 minus x1 squared plus y2 minus y1 squared, right? One of our points was -3, 3. That was our center. So that's going to be our x1, y1. And our other endpoint, what was it, b? B was at 3 and 12?
Yeah.
So we'll call that x2, y2. So I'm going to give that a try. Find out what the radius of the circle is. Plug it in. I'm going to give it a try.